In recitation 1, we're going to solve questions. We're going to start with dx over a squared plus x squared. But before we start solving, I need you to know all these derivatives. So what is the derivative of arc sine, arc cosine, and so on. Okay, let's solve the question. So we can take a squared outside. It's a constant. So it's going to be a squared 1 plus x squared over a squared. So it's going to be joined dx. So take a squared outside. It's going to be 1 over a squared dx 1 plus x over a squared. Take u to be x over a. Du will be 1 over a. We're doing this to have a form that we can predict like these ones. So basically arc sine can be 1 over 1 minus x squared. So we should be having one of these forms in order to continue. So we took u x is equal to x over a and du 1 over a. So dx is a. So it's going to be 1 over a squared dx 1 plus x over a squared times a. We can take a outside. In fact, we can cancel it with the squared here. And it's going to be 1 over a. This is u, by the way, because we chose it to be u. So integral of dx 1 plus u squared. Great. Now we have to predict which one will it be. So we have in the bottom 1 plus u squared, or basically 1 plus x squared. So this one, there's a root, there's a radical as well, radical, there's a negative here. So it must be this one, which is arctangent. So it's going to be 1 over a arctangent of x u, okay? It's u. You should put u here. Usually it's x, but this time it's u squared. So what did we choose u to be? X over a plus c, and this is your answer. All right, next question. Just the same, but we have a little difference. Same steps though. So let's take a squared outside first. So dx a squared from a squared minus x squared. So it's going to be 1 minus x squared over a squared, which will be x over a squared. And now take a squared outside with a radical. So it's going to be 1 over a dx 1 minus x over a squared. Take u to be x over a. So dx will be a. So it's going to be 1 over a, just like we did before, okay? So dx 1 minus u squared times a. We can cancel the a here and here. So it's going to be dx 1 minus u squared. All right, we need to predict which one will this be. So go to the table and check which one is it close to. So definitely not these. It's not a negative. And there's no radical this one. So it's probably this one, which is arc sine x. It's definitely this one actually. Okay, so arc sine of x squared, which is u here. So what did we choose u to be? X over a plus c. And that's it. All right, next question is pretty long and it's interesting. But once you solve this one perfectly, the other ones will be easy. So first we need to factor the bottom here. So let's take 2 outside. So it'll be 2 x squared plus 10x plus 25 plus 3, which is 28. Okay. Let's take 2 outside here. So it's going to be 1 over 2 dx x squared plus 10x plus 28. Now we need to factor even further. But if we put this in the calculator, this will give us an imaginary number, which we can't solve. So what we'll do is that we'll rewrite it. So I need to take this part here, x squared plus 10x plus 28. I need you to find b squared. What I mean is the formula is a squared plus 2ab plus b squared, right? But we are missing b squared here. this is not b squared, because if you put it in the calculator, it gives us imaginary number. So let's find b squared. So if a is equal to x and b, we don't know, so 2ab is equal to 10x. And a is x, so it must be 2 times something that is 10, which is obviously 10. 5, sorry. So b is equal to 5. What is b squared? It's plus 25. How do we go from 25 to 28? We add 3, right? So plus 3. Great. Let's read these then. Okay. So now we have something that can be factored. If you put this in the calculator, you're going to have, let me do it with you. So x squared is 1, 10, x is 10, and the constant is 25. It's going to be negative 5 twice, meaning that it's going to be x minus x plus 5 squared. Don't forget the plus 3. Great. Now let's switch this with what we were finding. Okay, from the very beginning. Actually here. This one here. Okay, so let's do that. So it's going to be half integral of dx over x plus 5 squared plus 3. All right, we're not done here. There's still some stuff we need to do. Okay, so first of all, let's take the 3 outside, because the form, let's check which form it is first. So it's x plus 5 squared plus 3. So there's x squared here and plus a constant here, or let's say 1. Okay, just for now, but later you can predict on your own. So x squared plus 1, which is it close to? X squared plus 1. So first of all, there's no radical and it's not negative, so it's definitely this one. So it's arctangent. So the form should be 1 over 1 plus x squared in order to change it to arctangent. So what we're going to do is change this to this one. So half dx, we need to remove 3 here. So what we're going to do is x plus 5 over 3 squared here plus 3 over 3, because we're taking outside here, right? We're taking 3 outside. So it's going to be 1 over 2 times, take 3 here, 1 over 3 integral of dx x plus 5 squared over 3 plus 1. Great, but we need to change this. And like the whole thing should be squared. So x plus 5 over radical 3 squared. Because now if we distribute the 2, it's going to be just the same as this one. Okay, so x plus 5 over radical 3 squared plus 1. Great, we reached. So 1 over 6, since 1 over 2 times 1 over 3. Now, we take q to be x plus 5 over radical 3. It will be 1 over radical 3, since x is 1. So dx is radical 3. Great. Let's make this neat. So 1 over 6 integral dx u squared plus 1 times dx, which is radical 3. Okay. Now, let's put it in the form. So we found that 1 u squared plus 1 is equal tangent, the arctangent, right? So let's write it down here. 1 over 6. We can take root 3 outside as well. So root 3 over x, over 6, sorry. Integral of dx u squared plus 1 is arctangent of u. Okay, this is usually x, but x here is u. So what is u? What did we choose u to be? X plus 5 over radical 3. X plus 5 over radical 3. And this is your answer. Alright, next example. We have this problem, which is very similar to what we just did. Just a little trick though. First, we look at the denominator. We have negative x squared minus 4x plus 5. So write it down here. And the negative x squared should have been negative. Okay, whenever there's x squared, try to remove the negative. So what we're going to do is remove the negative. It's going to be x squared plus 4x minus 5. Now, if you put this in the calculator, we're going to find an imaginary number, which we cannot solve. So what we're going to do is we find b squared, again, just like we did before. So x squared plus 4x plus b squared, which we will find. So a is equal to 1, while 2ab is equal to 4x. So b must equal to 2, since 4 divided 2. So b is equal to 2. So b squared, which is 2 power 2, is 4. Great. Now we need to find a variable here plus something that is equal to negative 5. So 4 minus 9 is equal to negative 5. Great. Don't forget the negative here. Okay, now we need to take 9 outside, the negative 9 outside. And in order to take it outside, we multiply negative by the negative here. So it's going to be 9 minus x squared plus 4x plus 4. Okay, and then we factor the x squared plus 4 minus 4 plus 4. So this will be x plus 2 on the calculator squared 9 minus x plus 4 squared. Okay, now we replace this here with the radical. So it's going to be integration of dx radical 9 minus x plus 2 squared. Great, let's have some space here. I'm going to take this here. Let me copy it. Okay. All right, now we need to figure out which form is this. I can tell you that there's a radical here and there's no negative, so it's arc sine. Well, let's look at the table. Look here, there's a radical and there's no negative. If there was a negative, it's going to be cosine. All right, you need to memorize these. Okay, so this should be in the form of 1 over 1 plus x squared with a radical. Great, so we need to remove the 9 and x plus 2 should be shortened. Okay, so let's see what we can do. So remove 9 first. dx 9, it's going to be 1 minus x plus 2 over 9, x plus 2 squared over 9. Great. So radical 9, let me add the integration. Radical 9 is 3, so it's going to be 1 over 3, and remove the 9 here. And this one should be u, but problem is x plus 2 over 9, the whole thing should be squared. So what we're going to do is that remove the squared here, square the whole thing, and radical the bottom, which is radical 9, which is 3. Great, replace this here. Okay, now u is equal to this part here, x plus 2 over 3. So x plus 2 over 3, du will equal to, since x plus 2 is 1, it's 1 over 3, and dx is just the opposite, it's 3. So let's rewrite it, 1 over 3 dx 1 radical 1 minus u squared. Great. Times dx, don't forget it. This part, this one here. All right, so now we can simplify 3 with 1 over 3, so these cancel. We can have dx radical 1 minus u squared, and this one is just arc sine. So arc sine of x, which in this case is u, and we chose u to be x plus 2 over 3 plus c, and this is your answer. All right, now next question. Okay, this is a little long, but it's easy. So we have to factor this first. So x squared minus 4x plus 3. Enter this in the calculator. You're going to find an imaginary number. So we're going to do it again. We're going to take x squared minus 4x. Take only this part first. Find b squared, which is b is 2. So b squared is 4. Okay, now look at this and check how can you go back to 3. 4 plus what is 3? It's minus 1. So first factor this. This will be, let me check. It will be 1, negative 4, 4. It will be equal to 2. So it's x minus 2 squared minus 1. All right, now replace this here. It's going to be dx x minus 2, x minus 2 again, squared minus 1. All right, we have x minus 2 on both sides, so why not take u as x minus 2? du will equal 1, so du is equal to dx. So it will look like this, dx over u radical u squared minus 1. Great, now we have to figure which form is this. We go back to the table. It has an x outside and x squared minus 1. Correct. The difference between these two is this one is negative and this one is not. Do we have a negative here? No. So it's secant. So, this is arcsecant of x, which here is u, and u we chose it to be x minus 2. So x minus 2 plus c. And this is your answer. Alright, next question. We have this problem. Alright, so we see at the bottom we have a common fraction. We can take x power 2 over 3 since 5 over 6 is bigger. So let's do that. X 2 power 3 over 3. Subtract 5 over 6 minus 2 over 3. Can use the calculator. It's going to be 1 over 6 plus 1. Okay, so it's 2 over 3 here. Okay, now let's take q as x power 1 over 6. Let's find the derivative. 1 over 6 x 1 over 6 minus 1, which is 5 over 6. It's going to be negative 5 over 6. All right, now dx is basically, let's put this together. So x negative 5 over 6 over 6, right? So in dx, we're just gonna switch them. It's gonna be 6 over x power negative 5 over 6. All right, so join this here. It's gonna be 1 over x power 2 over 3 u plus 1 times 6 over x negative 5 over 6. All right, we can join the x's here, this one and this one, where we add powers since it's multiplication. So 2 over 3 minus 5 over 6 will be x power negative 1 over 6. So x power negative 1 over 6, we can take this up. So let's do it here. X power 1 over 6. Remember we took u as x power 1 over 6. So actually we can replace this by u. So we can do that. And we have u plus 1 in the bottom. And this 6 can go outside. Okay, so it's going to be 6 here. Okay, great. We need to simplify this even further because we don't know the integral of u over u plus 1. So what we're going to do is introduce another letter and make this equal to w. So w is u plus 1. Okay, now find the derivative of dw, which is u is 1, 1 is 0. So dw is equal to du. So 6. And this u can also be written as in the form of w. So we know that w is equal to u plus 1. So if you want to solve for u, it's going to be u equal to w minus 1. So replace u as w minus 1 and u plus 1 as w. So u will be w minus 1 while u plus 1 will be w. Great. Now we can split this since now it's in the top. We can split it. Okay, so it's going to be the series of the integral of 6 w over w minus 6 the integral of 1 over w. Now find the integral. W over w is 1 and the integral of 1 is w since this is dw. Don't forget. So it's going to be 6 w minus 1 over w is ln, so 6 ln w. Now switch w to u. So w was u plus 1 here. So we're going to switch it by u plus 1. So 6 u plus 1 minus 6 ln u plus 1. Then also switch u. U is x power 1 over 6. And we will be solving questions here. X power 1 over 6 plus 1 minus 6 ln u is x power 6 1 over 6 plus 1. And that's it. All right, last question. This one is long, but it's easy. So, first of all, we need to factor the bottom, the denominator. So we can see that 4x is common between them. So let's take 4x as a common factor. Okay, so 4x, this one will be ln squared of x plus 8x over 4x is 2, ln x plus 12x over 4x is 3. Great. Now let's factor this. Before factoring, let's take q as ln squared to make this easier. Ln ln x. Yeah, let's take it as ln x actually. So you can have u squared plus 2u plus 3. So du is 1 over x. So dx is x. So this will be, we can take q at the top as well since it's also ln x. So 4x times u squared plus 2u plus 3 times x. We can cancel this x with this x here. And we're going to have 1 over 4 outside. Since x is cancelled, take 1 over 4 outside. Okay, great. Now let's factor this. So if you put this in the calculator, you're going to find imaginary numbers. So what you'll have to do is find b squared. So u squared plus 2u plus 3. Take this part, just treat u as x. Okay, you can do that. X squared plus 2x, it's the same if you're confused. Okay, so u squared plus 2u. Let's find b squared. So we know a is 1 and b is, so 2ab is equal to 2u or 2x. Okay, so b must be 1 because 2 times u times 2 is 2. So b is 1. So b squared is 1 squared or 1. So in order to make it the same as, to make it 3, we need to add 2. Okay, so leave the 2 behind. For now, factor this part here. And you're going to find, so x is 1, x squared is 1, and 2x and 1. It's going to be x plus 1 squared plus 2. Great. Now just replace. Let me delete this here. Delete. Okay, let's put this here for now. Okay, so let me rewrite this here. It's going to be 1 over 4 integral of u over this. Okay, so now we have x plus 1 plus 2. Where's the u? Hold on. Oh, okay, so we replace u as x. So just put it back as u. Okay, so we need to factor this. So we need another letter now. So w is u plus 1. So dw is equal to 1 and dw is equal to du. You can also write u in terms of w. We know that w is equal to u plus 1. So in terms of u, in terms of w, u is equal to w minus 1. Great, let's replace. So it's going to be 1 over 4 integral of w, can't see, minus 1 over u plus 1 is w, so w squared plus 2. Great. So now let's split. We can split since the top has minus. It can be plus as well. We can split. 1 over 4 w over w squared plus 2 minus 1 over 4 integral of 1 over w squared plus 2. Okay, great. Let's do the first part now. So we have 1 over 4 integral of w squared plus 2. Okay, so we need to, let's turn this to z. Okay, we need another letter again. So z is equal to w squared plus 2. So dz is equal to 2w, this is 0. So dw is equal to 1 over 2w. Okay, so let's replace here. So we have 1 over 4 integral w over z times 1 over 2w. I get the w here because we can cancel. So w, 1 over 2 goes outside. 1 over 2 times 1 over 4 is 1 over 8, integral of 1 over z. So this will be, this integral, 1 over z, is ln z. So 1 over 8 ln z. Great. So this is the answer for the first part. Let's delete what we did here. Okay, from here. Okay, let's do the second part now. So negative 1 over 4, 1 over w squared plus 2. Let's leave this full down. Let me change its color so I don't forget it. Okay, so let's solve this. 1 over 4 integral, there's a negative. We can leave this to the end, the negative. And 1 over w squared plus 2. Great. So first of all, we need to know the form of this. Which form does it look like? So first we see that there's a w squared. You can treat w as x and 2 as a constant. So 1 over x squared plus 1. We can switch its side as well. So it's going to be 1 plus x squared. So which one is this? It's tan. Okay. Arctangent. So we need this to be in the form of 1 over 1 plus x squared. So first of all, we need to move the 2. So it's going to be 1 over 4. 1, 2, take it outside. W squared over 2 plus 1. Okay, let's join w squared and 2 here. So this will be w over radical 2 squared plus 1. If we get the 2 here. Okay, so let's put this in the top here. Okay, now let's take u as, or actually another letter because we already used u. So let's use v as w over radical 2. So v prime or dv is equal to 1 over radical 2. So dw is equal to radical 2. We just switch. Okay. So what we have is negative 1 over 4 integral 1 over 2 v squared plus 1 times radical 2. So we can take radical 2 outside, and this 2 as well, we can take it outside. So what's going to happen is that's going to be negative radical 2 over 2 times 4, 8, and the integral of 1 over v squared plus 1. Right? So now we have the form of arctangent. We can change this to 1 over 1 plus v squared if you don't see it. But either ways, it's going to be arctangent. So arctangent of v. What is v? We chose to be w over radical 2. W over radical 2. Okay. So negative 2 over 8. Now we have this and this one here. Copy it. Paste it here. We can change its color back. White. And put it beside it here. Okay, great. Let me put the negative outside as well. Now, we need to change everything back. The letters, we don't want to see them. Okay, so what did we choose z to be? Z, we chose it to be w squared plus 2. So 1 over 8 ln w squared plus 2 minus radical 2 over 8 arc tangent w over radical 2. Now let's change w. W we chose it to be, what did we choose w to be? U plus 1. So it's going to be 1 over 8 ln u plus 1. Remember, only instead of the w. Okay, so what's going to happen is that it's u plus 1 power 2 plus 2. Then minus radical 2 over 8 arctangent w over radical 2. So w is u plus 1 over radical 2. Now once more, we have u. What did we choose u to be? U is equal to ln x. It's long, but it's easy. 1 over 8 ln u is ln x. So ln x plus 1 squared plus 2. And on the other side as well, we'll be done. arctangent Linux plus 1 over radical 2 plus C. And this is your answer. Thank you and consider subscribing.